Okay, class, welcome back. And today we are going to finish up chapter 3.6, variation. So this is going to be a quick video. We're going to talk about direct variation, inverse variation, and then combined and joint variation. So when one quantity is a constant, multiple of another quantity, the two quantities are said to be vary directly with each other. Okay, so for example, if you work an hourly wage of $10 per hour, then the pay equals 10 times the hours worked. Okay, so doubling the hours doubles the pay, tripling the hours triples the pay, and so on and so forth. This is stated more precisely as the following formula. So direct variation is where we have one variable is a constant multiple of another variable. So y equals some multiple of x. And so, in other words, another way of looking at it is if the ratio of two variables is constant, right? So if y divided by x is a constant, that also tells us that it's direct variation. Okay, so again, y varies directly as x, or y is directly proportional to x, and that word proportional gives us the division here, y divided by x. So if y is directly proportional to x, if there exists a non-zero number k called the constant of variation, that this is true. Okay, so in other words, if we have some two variables where the ratio of those two variables is a constant, then those two variables are directly related, or they vary directly with each other. So again, if one variable is also a constant multiple of the other variable, it's the same thing. So to solving variation problems, here are the steps. Step 1, you write the general relationship among the variables as an equation. Use the constant k. Okay. Now, step 2, substitute the given values for the variables that we know about, and then what we do is we find the value of the constant, right? So we got to solve for the constant. Once we know the constant, we know that never changes, so then we could substitute that back into the equation that we got in step 1, right? And then we obtain a specific formula for the given situation. And then 4, substitute the remaining values and solve for the required unknown value. So here's an example. The area of a rectangle varies directly as its length. If the area is 50 meters squared when the length is 10 meters, find the area when the length is 25 meters. So now all we have to do is go through these steps. So the first step is we're going to set up the general equation from the problem. Okay, so it says the area, right? So the area varies directly as its length. So that means A is going to be a constant multiple of the length. Okay? So we know that area is equal to some multiple of the length. Okay, where A represents the area, of course, and the L is the length of one of its sides, and K is a non-zero constant. So there's our formula. So now what we're going to do is we're going to solve for K because they give us information to solve for K. So we know that when the area is 50, the length is 10, or excuse me, that when the length is 10, the area is 50. Okay, so we plug in 50 here, plug in 10 here, and solve, and we find that K is going to equal what? 5. So now that we know the constant, now we can plug it back into the original equation, and we can say that A is equal to 5 times L. So here's our direct variation equation. And so now we can solve for the unknown that they're asking for, which in this case is area. So they want to know, find the area when the length is 25. So now all we have to do is add in 25. And when we add in 25, then we multiply by 5 and we get 125. And so the area is 125 when the length of the side is 25. So 125 square meters when the length of the side is 25 meters. Okay, so now what about the nth power? Direct variation as the nth power. The only difference now is now instead of y equals k times x, instead of having n equal to 1, now we're saying n is bigger than 1. Okay, so what we mean by this, the definition of direct variation as nth power, let n be a positive real number, then y varies directly as the nth power of x, or y is directly proportional to the nth power of x, if for all x there exists a non-real number k such that y equals a multiple of that power. So let n be a real positive number. So in other words, what we get here, so we have this, right? So now, if we have this, then what we say is this is inverse. Okay? So let n be a positive real number, then y varies inversely as the nth power of x, or y is inversely proportional to the nth power of x, if for all x there exists a non-zero real number such that this is true. Notice that now the x to the n is on the bottom. Then if n is 1, then we get this relationship where we say y is inverse relationship for y. So y varies inversely as x. So in other words, if we take the product of x and y, we get a constant. So that's another way of looking at it. If we take the product of two variables, if we know that the product of two variables is always the same, in other words, constant, then they have an inverse relationship. They vary inversely with each other. Okay? So in this case, y varies inversely as x. Okay? And so the only difference here is y varies inversely to the nth power of x. Okay? So we've got direct variation, where the ratio of the two variables is constant. And then now we've got inverse relationship, or inverse varies inversely. And in this case, if x times y is constant. Okay, and then of course we've got the powers as well. So again, make it be helpful to memorize and make sure you understand these formulas. So in this case here, this is what it would look like if it varies directly, right? So this is what it means. This is what it means, varies directly to the power of the power as a power of x, nth power of x. And here it is when y varies inversely as x, and then this is y varies inversely as the power nth power of x. So now let's look at this problem here. It says in a certain manufacturing process, the cost of producing a single item varies inversely as the square of the number of items produced. If 100 items are produced, each costs $2. Find the cost per item if 400 items are produced. So let's reread this. Let's make sure we understand what's going on here. So let's take it piece by piece. So it says, in a certain manufacturing process, the cost of producing a single item varies inversely as the square of the number of items produced. So this is an inverse relationship, but it's with a power of what? Of x. So this is a square. So what this means is that the cost, right? The cost C, let's say, is equal to some constant multiple of the square of what? The number of items produced, x. Okay, so that's the first thing, is we realize that y, let's say y is the cost, or we could use c, then c is equal to k times x squared in this case, where x represents the number of items, okay, produced. Okay, so in this case, y represents cost per item, X represents the number of items produced, and K is going to be our constant, or non-zero constant. So again, Y varies inversely, right? So Y varies inversely, which means X squared is going to be on the bottom, right? So this is going to be Y equals, I think I said it wrong. Yeah, now that I'm thinking, it's Y equals K divided by X squared. I think I said K times X squared, but I was thinking direct variation. So in this case here, it's going to be Y is equal to K divided by this X squared, okay? So now this is the formula. So this is really half the battle right here. Once you know this, then we can, now that we can go to the next piece of the pie, okay? So in this case here, it says if 100 items are produced, then we are told that each costs $2, okay? So that means what? X is 100, and then Y is $2 per item. Okay, so again, so we're going to use this. Okay, and now what we're going to do is solve for K. So we know that this is what? 2, and X is 100. And so now what do? Solve for K. And so we find that K is 20,000 in this case. Okay, so now what do they want? They want to know what the cost is, right? If we have what? I think it was, I'm not going to go back, but so here's our formula. So now that we found the constant, we can plug back in the constant. So this is our formula. So this is what we're going to use to solve for solve the question. And so it says when 400 items are produced, the cost of the item is what? That's what we're trying to figure out, the cost. If 400, so now we're going to plug in 400 here, and now we're going to get 400 squared, and we're going to divide that into 20,000. So we get 0.125, or 12.5 cents. So if we produce 400 items, now the cost the cost per item goes down significantly, so to 12.5 cents per item. Now, joint variation. Joint variation is a situation where you have both direct and inverse relationships going on in one formula. In other words, you have multiple variables where one variable varies directly with another variable, and then the same variable varies inversely with another variable. And so when we say varies jointly, we know that there's both things going on, and there could be powers involved in both of them. So now in joint variation here, or excuse me, I'm sorry, I said directly and inversely with it. No, they're both directly. So in this case here, when we say varies jointly, we mean that Y, for example, varies directly with X, but it also varies directly with Z as well. And notice that there's powers here involved. So you could have powers involved. And so there's a constant here. So when we say varies jointly, we have three variables where one variable is varies directly with the other two variables. So then we have a situation like this where we have y is a constant multiple of these other two variables, the product of these other two variables, and of course we could have powers involved as well. Okay, so this is the general formula for varies jointly. So anytime it has, like if it varies jointly with two other variables, this is going to be the setup, depending on if they're squared or cubed or whatever the case may be. Now we got to make a caution here though. So it says note that and in the expression y varies jointly as x and z, translates as the product of y equals kx times z. Okay, so the word and does not indicate addition here. Okay, so be careful. Okay, it's the product. It translates as the product in this case, x times z. Okay, so just be careful. It's just saying it varies jointly among both of them, and so in this case it's a product. So here's an example. So the area of a triangle varies jointly as the length of the base and the height. Okay, so as the height increases, the area is going to increase. As the base increases, the area is going to increase as well. Okay, so so there it is. So a triangle with a base of 10 feet and a height of 4 feet has an area of 20 feet squared, 20 square feet. Okay, so we can use, and of course you can verify that that's true. It says find the area of a triangle with base 3 feet and a height of 8 feet. Okay, so how do we do that? So we have this information here, okay, but we want the area of a triangle that's 8 with a height of 8 and a base of 3. Okay, now obviously we can solve this by using the formula of the area of a rectangle, but let's use the information and use it as a joint variation type problem. Okay, so what do we have here? The area, so area varies jointly as the length of the base and the height. So let's say B is for base and H is for height. So we know that this is going to be of the form A equals some constant K times B, the base, times the height. Right? And we already know that what that constant is going to be if you remember the formula for the area of a triangle. It'll be 1/2 because we know the area of a triangle is 1/2 base times height. But let's prove it using joint variation. So we know that A is equal to K times B times H. And now we give the information about the first triangle. 20, A is 20 when B is 10 and H is 4. So now we're going to solve for K, right? And so what do? We multiply and we get 40, and then we divide both sides by 40, and we get K is equal to 1/2. And then we get the area of a triangle. Area equals 1/2 base times height, okay? And now we can plug in the information from the second triangle and figure out what the area of the second triangle is. And now we can solve for the area of the second triangle as 12 times 12 square feet. So now let's look at this problem. Now a combined variation problem has both things going on. Okay, so in this case here, it says the number of vibrations per second, which is the pitch, of a steel guitar string varies directly as the square root of the tension and inversely as the length of the string. Okay, so the number of vibrations per second, the pitch, so the pitch of a steel guitar string varies directly as the square root of the tension and inversely as the length of the string. So we've got two things going on. Okay, varies directly as the square root. Now in this case here, it's this and, right? Now it doesn't say jointly, so it says directly as the square root of the root of the tension. So where's that one going to go? Well, it's going to be the square root. So since it's directly, it's going to be of the form y equals kx, right? So in this case, let's say P is the pitch. And, well, I don't know how they're going to define it, but it could be XYZ. So let's go with there. So let n equal the number of vibrations per second, right? So n is the number of vibrations per second. T represents the tension, and L represents the length of the string. Okay. Then from the information in the problem, we can write the variation equation this way. So we know it varies directly with the square root of the what? The tension. So we're going to have the square root of t. So we're going to have k. K is going to be a positive constant. So n is going to equal k times t, the square root of t. And since it varies inversely with the length is going to be in the denominator. Okay? And so this is what we're going to end up having. So n equals k times the square root of t, because it varies directly with the square root of t, but it varies inversely with L. So then this is going to be our equation. Then what we're going to do is we're going to use the information to solve for k. So we're going to substitute in the values that we know. So we know that n is 50, and then t is 225, and then L is 0.6. And so now if we solve for k, we find that k is equal to 2. And now we can go back, and now we have our formula, which is n equals 2 times the square root of t and L. And now what we can do is we can plug in t and L and find the pitch. And so if we plug in all the information, we find that the pitch, the number of vibrations per second for the string, is going to be about 43. Okay, so approximately 43 vibrations per second. Okay, so that is the end of this section, and that wraps up Chapter 3. Again, if you have any questions, please make sure you bring them to class. If you get stuck in any of these or you're not sure how we work these out, again, also do more of the examples in the textbook. There are other examples, and there are definitely some exercises at the end of the chapter that you can also practice with. And then if you get stuck on one of those, or if you want to see if you got the correct answer, bring those to class and we'll work them through. Okay, until then, have a great day.